Welcome back to the Deep Dive. Today we're looking at a really specific piece of pro video gear, the Bluefish444 EB3007B Epoch Neutron card.
Yeah, this one's definitely aimed at the high end of the market.
Right. So our mission, as always, is to dig into the specs, the tech docs, and figure out what makes this internal PCIe card tick, and maybe why it lists for just under $2,000.
Mm-hmm. It's clearly positioned beyond just basic input-output.
Exactly. This isn't your standard capture card. The documentation points to it being a dedicated 2K video engine, really engineered for, well, super low latency and serious professional color depth.
That low latency part is often key in these devices.
Okay, so let's unpack the basics first. Hardware-wise, what are we looking at?
Physically, it's a full-height, half-length PCI card. Needs a 4-lane slot. And importantly, it's compatible across Mac, Windows, and Linux systems.
Pretty standard form factor then. So what does that architecture actually get you connection-wise? What's the I/O situation?
Okay, this is where it gets interesting. You've got 3 BNC connectors on the back, but they're independent and simultaneous bidirectional HDSD SDI ports.
3 bidirectional SDI. Okay. What does that configuration unlock?
Well, that setup is what allows you to capture or play out video up to DCI 2K resolution at 60 frames per second using dual-link HD SDI.
Hold on, DCI 2K 60. We should probably clarify for listeners, DCI 2K isn't quite the same as standard broadcast HD, right?
Correct. It's the digital cinema standard. So a bit wider, slightly higher resolution than full HD. Gives you that cinematic canvas, essentially.
Got it. And the name mentions a dedicated reference connector. What's the story there?
Right, so it does have its own dedicated BNC input just for reference sync, like Blackburst or tri-level sync. But, and this is pretty clever, you can actually configure one of those 3 bidirectional SDI ports to act as a second reference input if needed.
Ah, so you sacrifice one video I/O channel for redundant sync.
Exactly. Or just for flexibility if you have multiple sync sources.
Why the redundancy? Is that common?
In mission-critical setups, absolutely. Think live broadcast or maybe complex stage events. If your primary sync signal drops, you need that backup. It's about stability. Plus, you also get a simultaneous HDMI output right off the card for monitoring.
Okay, so that's handy for just checking the output locally without needing another converter box or tying up an SDI output.
Precisely. Keeps things streamlined.
All right, let's move inside the card to the processing power. The specs highlight things like 12-bit processing, a 4x33-bit color matrix, and 256 megs of RAM on board.
Yeah, that 12-bit processing, that's actually huge. It's not just a slightly bigger number than the usual 10-bit.
What's the practical difference?
It really helps eliminate color banding, those nasty steps you can see in gradients, especially after heavy grading or compression. For high-end post, QC, digital intermediate work, that kind of fidelity is, well, it's pretty much mandatory.
Makes sense. And the docs talk about extremely low latency of sub-on-field or frame for SDI I/O. Can you translate that from engineer speak?
Yeah. It basically means the delay between input and output is less than a single field of video. That's incredibly fast. We're talking almost instantaneous transfer.
Wow. How does it achieve that?
A big part is the full duplex DMA engine. DMA, direct memory access, lets the card move video data directly to and from the host system's RAM without bogging down the main processor, the CPU.
Okay, so it keeps things moving quickly even when the computer's busy.
Exactly. And then you've got these high-performance bypass relays built onto the card.
Bypass relays, what do they do?
They're a physical fail-safe. If the computer itself crashes or loses power, these relays automatically connect the card's input directly to its output. The video signal keeps flowing through, uninterrupted.
Ah, so even if the system goes down, the signal chain isn't broken. That's vital for live stuff.
Absolutely critical. It speaks again to that reliability focus.
And this reliability idea extends to workflow too, right?
Yeah.
It's an internal card, but you mentioned options.
Yeah, you can install it in external Thunderbolt enclosures, like ones from Sonnet. That gives you portability. Or lets you use it with systems that don't have internal PCIe slots.
And you could potentially put other cards in that enclosure too.
That's right. Some enclosures let you add maybe a fast PCIe SSD or a RAID controller alongside the Epoch card. Builds a pretty powerful mobile setup. Plus, Bluefish444 includes their Ingestore software for capture and an SDK for developers.
Right, the SDK opens it up for custom integration. What about other built-in features?
Well, another big one is the hardware downstream keyer, the DSK.
Hardware DSK, meaning?
Meaning it can overlay graphics or titles directly onto the video signal on the card itself. It doesn't rely on the host computer's CPU or GPU for that, which saves resources and, again, reduces latency. Perfect for live graphics.
And audio.
Pretty robust there, too. It handles 16 channels of embedded SDI audio input and output, and it supports pass-through for Dolby Digital signals embedded in the SDI.
Okay, so tying this all together, the DCI 2K, the super low latency, the redundant reference, the hardware keyer, the bypass relays. This thing is clearly built for tough jobs.
Yeah, you're looking at broadcast graphics, serious post-production, live event production, maybe digital intermediate suites, quality control stations, even video over IP gateways, and high-end streaming setups.
So the value proposition seems to be that blend of flexible DCI 2K performance with really professional-grade, almost fail-safe reliability.
That sums it up pretty well. It's a specialized tool for workflows where speed and dependability are paramount.
So we leave you with that image, the EB3007B Epoch Neutron as this robust, professional 2K engine designed for demanding scenarios.
Which does make you think, given that focus on extremely low latency and those hardware bypass relays, how might that combination change how we design for reliability, especially in, say, permanent unmanned installations like remote broadcast links or automated QC farms? Could that level of hardware fail-safe reduce the need for some other kinds of system redundancy, something to maybe chew on until next